We'll start by reading the problem. The coefficient of variation CV describes the standard deviation as a percent of the mean. Because it has no units, you can use the coefficient of variation to compare data with different sets. Find the coefficient of variation for each sample data set. What can you conclude? And you're given the following formula. And it is CV is equal to standard deviation divided by the mean times 100%. You need to have a data set in order to be able to calculate the mean or standard deviation, or you need to be given the mean and standard deviation. These are the data sets that we're going to use, and notice what I did when I brought this up. I went ahead and I clicked this icon that says click the icon to view the data set. This particular icon is going to bring up a data set that's going to allow me to copy the data set or just use the data set on paper and using paper and pencil. If I left click it, I bring up the data table and I have two columns, heights and weights. I need to find the standard deviation and the mean for this. The reason that I need to do that is because I am going to be working with the coefficient of variation, and as I said, the CV formula is given by the standard deviation divided by the mean and we're going to multiply that by 100%. Now let's just assume that the standard deviation is equal to 2.54 and the mean, whatever it might be, will be equal to whatever the data set is. Let's say it's 27.4. Now I want to go ahead and find the CV. The CV will simply be found by taking the 2.54 and we're going to divide that by 27.4 and we're going to multiply that by 100%. And you'll simply type this into your calculator, do the 2.54 divided by 27.4, multiply it by 100, and you will end up with 9.27, and it's a repeating decimal, but notice that it says round to the nearest tenth as needed. So it will be 9.3 will be my coefficient of variation for these two made up standard deviation and mean. Now let's go ahead and actually work the problem. So we're going to copy the values, the data. We're going to left click. We're going to left click open in StatCrunch. Now, notice what I did to do that. There is always going to be an icon that looks like this near data tables. And you will left click that icon in order to open up the data set. We're going to copy it either to the clipboard, we're going to open it in Excel, or we're going to open it in StatCrunch. If we copy to the clipboard, it will just copy the data and you can paste it into some function. If you left click open in Excel, if you left click that, it will bring up a download window. You'll left click save and then it will download the file, and once it's downloaded you can go ahead and click it and it will open up in Excel so that you can use the data. You'll notice that it's opened in protected view, and it depends on what your security protocols are, but in order to do anything with this you would left click enable editing so that you can then go ahead and find the standard deviation and the mean for these two sets. But we're going to use StatCrunch to actually find the standard deviation and the mean. We'll left click this, we will left click open in StatCrunch, and it will open up in another browser window. Now you can maximize this if you want, you can stretch it, do whatever you want. But basically what I'm going to do is I'm going to left click stat, and I'm going to left click summary stats, and I'm going to left click columns. I want to find the mean and the standard deviation for both of these columns. So we'll left click height, and you'll notice that it populates in this window over here. Press and hold your control key and left click weights, and you'll see that both of these pop in over here. Now, like I said, we need to find the mean and we need to find the standard deviation of these. But I want to go back to the main page for just a moment so that we can look at something. Notice that it says find the coefficient of variation for each sample data set. This is the key, sample, okay? Because in StatCrunch, you need to be able to differentiate between a sample and a population. If you left click mean, you will find the mean regardless. But if you left click standard deviation here, notice that both of these populate this window. This standard deviation is for a sample size. Down at the bottom of this list, you will see the fact that there's an unadjusted standard deviation, and that would be for a population. While we're at it, let's look and see there's coefficient of variation right here also. So I'm going to left click that so that I now have mean, standard deviation, and coefficient of variation. I will left click compute, and I have this pop-up window that shows up. Now what's cool about the pop-up window is that the mean is calculated for both sample sets. The standard deviation is calculated for both sample sets, and the coefficient of variation is also calculated. But let's just double check and make sure that that coefficient of variation is accurate. So for heights, and we'll just use h, remember that the formula is standard deviation, which in this case for heights, our mean will be 74, and our standard deviation will be 3.95428842. Now, I recommend that you do your rounding at the last possible minute. So we'll go ahead and we'll type or write in the standard deviation of 3.9542842, and we will divide that by the mean of 74, and then we're going to multiply that by 100%, and let's see if we get the same exact value that we had previously as contained in our table right here of 5.3436273. Now make sure that you have a good scientific calculator. If you don't, there are web-based calculators, and I recommend Web 2.0 calc.com. Now here is the URL, and it's a solid URL. And we'll go ahead and we'll type in this formula that we have right up here. So we'll type in 3.9542842. We will divide it by 74, and then we'll multiply that by 100. Notice that right here it tells you exactly what you've entered into the calculator, and it does match what we have written over here on the right hand side of the screen. So then we'll just simply left click equals, and we come out with this big long number. Now you got to remember that you just need to round to the nearest decimal, or I should say nearest tenth unit, so a single decimal place. But I want to go ahead and write out 7 decimal places so that we can compare what's in the table that we just calculated. So I'm going to write out 5.343622729. Now once I've done that, let me go ahead and minimize this so I can look back at what I have in my table. Notice that I have 3.9542842. I'm sorry, that's the standard deviation. I meant for the coefficient of variation is 5.3436273. Now, you notice that if we round what we have over here, if we round it to this decimal place, we'll have the exact same value. But as I said, we just need to go ahead and use one decimal place. So we'll go ahead and enter 5.3 rounded to one decimal place, or the nearest tenth. We'll go ahead and left click check answer, or simply hit the enter key, and I get the correct answer. Now it wants to know what the CV of weights are. So we'll go back to StatCrunch and we'll look here, and we don't have to calculate it again. I was just doing that to show you that my answers are going to be correct here, and we'll type in 9.3. Hit enter, it checks, and then we'll move to the next question. What can you conclude? Well, if the coefficient of variation is smaller, that means that that's not as variable data set. The larger the coefficient of variation, the more variable the data set. Now, since for this one, the heights, CV of heights, and let me write this out here, and I'm just going to use H, is equal to 5.3%. And then we'll look at the coefficient of variation for weights. That's going to be CV sub W, which will be equal to 9.3%. Well, this is a more variable data set. And that should make perfect sense, because if you think about it for a moment, when you look at that, the standard deviation was higher. And if the standard deviation is higher, then that makes sense. But I can't simply go by the standard deviation in these, because these are two different units. Heights would be linear measurement, such as feet or meters. Weights would be in terms of pounds or kilograms. So I can't really compare them until I do this calculation to get the two different coefficients of variation. So we will say that weight is more variable than height. And then we move on to the next question.